All right, let's do another one. We're gonna do another medium one, blind. So I have no idea what my strategy is gonna be here. It was a mistake last time. Let's see if it's a mistake again. Integer to Roman. 7 different symbols represent Roman numerals with the following values. Um, Roman numerals, yeah, we know how Roman numerals go. And then we have to also consider that there's the subtractive form of I before X, I before V, except after C. Um, Only powers of 10 can be appended consecutively at most 3 times to represent multiples of 10. Okay, awesome. So I don't think that this is going to come into play because I think that if we do this the way that I'm thinking, I don't think that this will ever happen. So, what's the strategy? I'm thinking that we just, well, it kind of honestly describes the number right here. Um, but I'm thinking just take the num and you subtract biggest possible Roman numeral as many times as you can. And the only other consideration we make is how to subtract it. But my idea, I think I have an idea, which is to kind of like just basically treat all of these combinations the way I would treat any other Roman numeral in this process. So subtract, add biggest subtractive forms at list, and then this. So I feel like one way to do this would just be to do a while loop until the number reaches 0 and just do the same thing multiple times. Just try to subtract the biggest number possible from it. But I've got a different idea. What if we do? It's going to be kind of ugly, but I think it'll be a little bit faster because like once we eliminate the first 1,000, like once we get the number to be down to less than 1,000, we really don't need to be checking again to make sure it's more than 1,000. That's needless. So why don't we try just doing a different while loop for every possible value and every possible subtractive? It'll be a little ugly and it'll definitely be a lot of lines, but I think it'll be all the same and it'll be the same, essentially the same function, the same loop over and over again. So just do a while loop to subtract every time. And we don't even need to do a while loop for these guys or the fives because they'll already, if there are multiple fives or multiple fours, they'll already be subtracted. Basically, there's no situation where you can't have multiple fives because the 10 will already have been subtracted from it. And you can't have too many 10s because you basically work your way down. You always subtract the biggest number first. Makes sense. Okay, let's do it. So, Roman equals blank. And we're just going to keep on adding to this as we go. So, while num is greater than or equal to 1,000, num minus equal 1,000, and then Roman plus equal m. Okay. Either I'm stupid or this should just be pretty smooth sailing from there. Okay, next. We actually only need to do that. We don't need this to even be a while loop. We can just have this be an if statement. But now let's worry about if we have DM? No, not DM. Only CM is it? No, yeah, CM. So let's see if we can fit 900 into this number, because we want to fit as big numbers as possible. So we can just say, while if num is greater than or equal to 900, num minus equal 900, Roman plus equal CM. Okay, cool. And then we just basically keep doing that, right? Yeah. I'm just going to return Roman at the end before I forget. Let's see, what's the next biggest one that would fit in there? It'd be D. We can't do multiple D's. In fact, that would never be a situation. If num is greater than or equal to 500, num minus equal. So, like, as I think about this, like, we could just do, like, a dictionary or something and have the value, basically flip it so that the values were the keys. But honestly, I kind of think that this way is going to end up being faster, because it doesn't need to access a dictionary every time. We know what the values are going to be, and there's only a small handful of them. So we don't need to access the dictionary every time. We can just work our way down. Once we're done with the thousands, we never have to think about the thousands again. Okay, Roman plus equal C, or D. Okay, this is easy enough, I think. I could be totally wrong. If num... Okay, now we need to go back to the... Nope, now we try to fit a 400 in there. Okay, yeah, this is making sense. Because, like... Yeah, we're saying, like, okay, if... As we make the number smaller, we're trying to see if we can fit, like, the biggest number remaining that we can fit in there. So if it's 400, then we add CD. And we'll never have DCD, because that would have been removed by the CM. Alright, cool. And we'll never have multiple CMs, because those would have been removed by the thousands. So the while loops are for the ones that can be appended consecutively, and everything else can just be an if statement, since it can only happen one time. Okay, now we're just down to C, I'm assuming. Yep. Greater than or equal to 100. Num minus equal 100. Roman plus equal C. Okay. You know, I'm just going to do that for the remaining. So we got 10, and then we got 1. Cool. Yeah. I'm curious how fast this will work. Maybe I'm totally wrong, but I think this will actually work really fast. Because it never checks something that it already knows can't be true. Once it's done checking the thousands, it never checks that again. And these comparisons will be really quick. So, like, even if it's not the fastest, I can't imagine it being that slow. Because just comparing two numbers and just subtracting two variables, or subtracting and adding. Okay, so let's see. In between the 100 and the 10, we have the 90. And the 40. And the 50. Okay, makes sense. XL, and then we just have IX and IV. Oh, and V. And then these will just be, yeah, so these are just if statements because they're never going to happen more than once. Yeah, so this is a neat question. It's just kind of making you think about you know, the structure of these numbers and how they're built. Alright, cool. Not really the most intense coding question, at least the way I'm going about it. If it's greater than or equal to 4, if it's greater than or equal to 9, and if it's greater than, or no, 5. It's all about the sequence. 4, 5, ix, v, iv. Cool. That seems pretty straightforward to me. Let's see if that worked. Invalid syntax. Oh, yep. That's not a thing. There's an accidental colon. Oh, I did that again, didn't I? Silly homie. Oh, hey, come on. I don't want to pay. Let me try again. Yep. Come on, is there an edge case I didn't consider? No, there's not. And yeah, 50 and 50. Makes sense. I'll take that. Give me a little applause there. I think the applause is for the top half. Yeah. Alright, cool. Makes sense to me. There probably is a faster way to go about it, because if you're dealing with maybe small numbers, you really don't need this big stuff up here. Maybe we could say if it's ever 0, return. I'm curious if that would make it faster. I'll just put this after every single possible condition. Maybe give it an out. Let's see. So runtime is 52. This is... I mean, I'm happy with the result. I'm just curious if I can make it work faster with this quick fix. I'm just basically saying, hey, if it's just 1,000, we don't need to check all the other numbers. Let's see if that works. Oh, no, that made it way worse. That makes sense. It's a lot of conditions that were unnecessary. Yeah, unnecessary. Yeah, I don't think I'm gonna get much faster than that. At least without rebuild. What the heck? Okay, so maybe I shouldn't really judge runtime that harshly, because that just seemed like a luck of the draw, maybe. Because that just beat out 98% of people. Okay, cool. I mean, that's what I thought would happen, actually, because I just can't imagine there being a faster way of going about this. Because sure, while it is ugly to hard code different numbers in the code, I think it is faster, because the alternative is having to have some system where you have to constantly figure out what number is what letter, as opposed to this, where it's just, okay, get rid of the M's, get rid of the CM's, get rid of the D, get rid of the CD, and so on. I think this is as fast as you can get. It's like a fixed number. Yeah. Okay, makes sense. Cool. Yeah, that was a fun one. I'm back on track. All right. Thanks for watching. See you later.